Hi everyone, Assalamualaikum warahmatullahi wabarakatuh and good day to every one of you. Welcome to my video. So basically this video is a continuation of lecturer video for subject Electrical Circuits 1, code BEV 10303, and in this video we are going to continue our discussion for chapter 2, which is Basic Law of Electric Circuit. Okay. In this video, we are going to cover the last subtopics, which is Wye-Delta Transformation. Okay, so we will see in detail on how to transform from the Y network into the Delta network and from the Delta network to the Y network. Okay, so now let's have a look at the introduction for the Wye-Delta transformation and why do we really need the transformation. Okay, so basically there are cases where the resistor are neither parallel nor series. It means that the resistor is not even parallel and it's not even in series. So for example, we consider the bridge circuit shown in this figure, okay, where you have a supply Vs connected to the R1 and then R1 is connected to this bridge. Okay, so this circuit, we call it as a bridge circuit. So let's say from the question, it asks you to calculate what is the value of I. As you might know, by applying the Ohm's law, I is equal to Vs divided by R equivalent, right? Okay, I equal to V over R. So R equivalent is equal to the combination of R1 and R2, R3, R4, and so on. Okay, so but because of R1 is not even the connection between R1 and this bridge, it is not even in either parallel or it is not even in series. So that's why we need to do the transformation, so that by using the transformation, we can find what is the R equivalent, and then based on the R equivalent, then only we can calculate the value of I, right? So this circuit is actually can be simplified to the 3-terminal equivalent, right? Okay, so that's the purpose on why we do need to do the transformation, right? Okay, so we had know why do we need to do the transformation. Okay, so next let's have a look what are the topology that we can transform. Okay, so first of all, there is two topology that you can interchange to each other. The first topology is the Y network, or we can also call it as a T network. So this basically, you can see like you have R1 connected to R2 connected to R3 like this, and then you can see it is in Y shape, so that's why we call it as a Y network. Okay, it can also consider to be written in this network. So these two is equivalent to each other. And then the other net topology is we call it as a delta network or pi network. Okay, so basically this circuit represent the delta network, where RA connected to RB connected to RC in this configuration. Okay, and then it can be redrawn in terms of pi network like this. So both of this circuit also equivalent to each other. Alright, so by transforming between these two topology, okay, so actually you can transform from Y delta to the from Y network to the delta network, or from the delta network to the Y network. So transforming between these two topology usually often makes the solution of the circuit easier. So meaning that, let's say the question asks you to calculate the current, to calculate the voltage, by using the transformation, it can help you to solve the circuit better, alright? So how to do the transformation actually? How did you transform from Y to delta and from delta to Y? So usually we can do the transformation by using the superposition Y and delta network. Okay, so this is what we call as a superposition Y and delta network, where you have the interconnection between the Y network and the delta network in the same figure. Alright, so the delta network usually consists of the outer resistor. So the outer resistor represent your delta network, where you have a RA here, RB and RC, and then your inner network, okay, your inside network represent by your Y network. Okay, you have R1, R2, and R3. So the combination of the Y and the delta, we call it as a superposition Y and delta network. Alright, so based on this, there is a formula on how to calculate the R1, R2, R3, and RA, RB, and RC. Okay, so let's have a look at the next following slide on what are the formula for each of the resistor, right? Okay, so how to transform from Y to delta? Okay, so let's say you are given the Y network. So you have a Y network, you have R1, R2, and R3. So you need to convert it to become delta. So how to calculate the value of RA, RB, and RC? So the conversion formula from Y to delta is given by, let's say you want to find the RA. So RA is here. So RA is here because A is connected to the R1. So you put the R1 as your denominator. Okay, so RA is equal to R1 multiplied with R2. Sorry, RA is equal to R1, R2 plus R2, R3 plus R1, R3 divide by R1. Okay, remember when you want to calculate your RA, A is at this point. So that's why you divide by R1 because here R1 is your denominator. For RB, okay, RB here is your B point. So for B, B point is connected to your R2. So that's why R2 become your denominator. For the numerator, for your upper side, is remain the same for each of the formula. Here you have R1, R2 plus R2, R3 plus R1, R3 over R2 because RB. For RC, okay, you see RC is the C point is connected to the R3. So that's why for RC, your denominator is the R3. So that's how you memorize the formula, okay? So later we are going to see in details on the example on how to do the conversion, okay? So for the time being, we just need to understand on how to derive the equation, okay? And sorry, how to memorize the equation. All right. So this is for the conversion from Y to delta. And then next, how to do the conversion from delta to the Y. Okay, for delta to Y, so you need to find the value of R1, R2, and R3. So based on here, you are given delta network. So you are given the value of RA, RB, and RC, but you don't know what is the value for R1, R2, and R3. Okay, so how to memorize the formula? So for R1 is like surrounding by RC and RB. R1 is surrounding by RC and RB. So that's why R1 is equal to RB multiplied with RC over RA plus RB plus RC. Okay, how about R2? R2 is here. R2 is surrounding by RC and RA. Okay, again, R2 is surrounding by RC and RA. So that's why R2 is equal to RA multiplied with RC over RA plus RB plus RC. Okay, for R3, how about R3? R3 is surrounded by RA and RB. Okay, so that's why R3 is equal to RA, RB divided by RA plus RB plus RC. Okay, again, for this formula, the denominator remain the same for each of the formula. The only difference is the nominator side, at the upper side. Okay, here you have R1, RB, RC. Here R2 is RA, RC. Here R3 is RA, RB. Okay, that is how you can, that is some of the way on how to memorize the formula. Okay. Okay, so next, let's have a look at the following example on how to do the conversion. Okay, so based on the example 2.11, for the following circuit, convert the delta network, here you have delta network, to the equivalent Y network. Okay, so based on the delta network, the question giving you the value of RA, RB, and RC. So meaning that you need to find the value of R1, R2, and R3. Okay, so first of all, we can just draw the circuit first. Okay, so based on the delta, you need to transform into the Y network. So we do the superposition network first. So from the point A, sorry, you can just like draw the network first. So you have the one first, and then the second resistor, and then the third resistor. And then after that, which one is your R1, which one is your R2, and which one is your R3, right? So how to identify? So you have point A here. Point A is connected to the R1. Okay, so point B is connected to R2, and point C is connected to R3, right? So, and then after that, how to calculate the value of R1, R2, and R3? Okay, so based on the formula, R1 is equal to, you see, R1 is surrounded by RC and RB. So that's why you have RB, RC divided by RA plus RB plus RC. Okay, like that. So how about R2? R2 is equal to R2 is surrounded by RC and RA. RC and RA. So that's why you have RA, RC divide RA plus RB plus RC. Okay. And then how about R3? R3 here is surrounded by RA and RB. Okay. So that's why you have RA, RB divided by RA plus RB plus RC. Okay. So once you get the formula, you can just substitute the value of RA, RB and RC. So here from the question, RA is given by 15 ohm, RB is 10 ohm and RC is 25 ohm. So you just substitute to the formula. Okay, so RB, RC 10 multiplied by 25, and then RA plus RB, RC is 15 plus 10 plus 25, and then finally you get R1 is equal to 5 ohm. Same goes to R2, you just substitute the value, you get 7.5 ohm, and R3 you can get the value is 3 ohm, right? So the all these three you just need to key in into your calculator to get the value, and then after that you can draw your Y network. Okay, so your Y network is given by this figure. You have R1 here, R2 here, and R3. Okay, which each of the value lah. Alright. So that's all. That's how you do the transformation. Okay, so now let's have a look at the following example 2.12, where you are going to apply the transformation Wye-Delta network techniques that you learned just now in order to solve the circuit. Okay, so you need to solve the circuit, meaning that you need to find the value of I. So based on the circuit, okay, so you need to obtain the equivalent resistor first. So the equivalent resistor in this case, we call it as a RAB or R equivalent. So you have point A, you have point B, so that's why you need to find the RAB. And then based on the RAB, you can find the value of I, where I is equal to V over RAB. So V is 120 divided by your RAB. So as you might see from the circuit, each of the resistor is connected to each other, but it is not in terms of series and it is not even in parallel. So that's why how to calculate the value of RAB. So you need to do the transformation technique. Alright. Okay, so first of all, based on the circuits given, I need to draw the topology first. So here you have 10 ohm, 5 ohm and 20 ohm is connected to each other by the Y topology, and then I need to draw my delta topology. Okay, so I have here, resistor connected to this point, and then here I got another resistor connected to this point, and another resistor connected to this point. Okay, so from here, I don't know which one is my R1, which one is my R2, R3, RA, RB, and RC. So from A, the whatever resistor that connected across it, so here is my RA. Okay, so here from C, point C, whatever resistor that connected across it is RC. For point B, whatever resistor connected across it is RB. Okay, how about R1, R2, and R3? Okay, let's change the pen color. So A resistor that connected to the point A is R1. Resistor that connected to the point C is R3. And resistor that connected to the B point is R2. Like that. Alright. So in this case, you can simplify it. So your R1 is equal to 10 ohm. Your R2 is equal to 20 ohm. And then your R3 is equal to 5 ohm. Okay, so how to calculate the value of RA, RB, and RC? You can use the formula. So you have RA is equal to R1, R2 plus R2, R3 plus R1, R3 divide by, so again RA, so point A, the whatever resistor that connected to here is R1, so that's why here you have divide by R1. The same goes to RB. So RB for the numerator is remain the same. So you have R1, R2 plus R2, R3 plus R1, R3 divide by, here you have RB. So RB at the denominator is the R2. Okay, so RC is equal to R1, R2 plus R2, R3 plus R1, R3, okay, divide by, so RC is point C is connected to R3, so that's why the denominator become R3. Okay, and then after that you can just substitute the value of R1, R2 and R3 into this formula, this three formula, then you can find the value of RA, RB and RC. Okay, so I by using the formula, I just substitute the value R1, R2 and R3. So after I substitute the value, I get RA is equal to 35 ohm, RB is equal to 17.5 ohm, and RC is equal to 70 ohm. Okay, so based on the figure that you have just now, you can redraw your circuit into this one. Okay, from the previous slide, you have now you have RC is parallel to the 30 ohm. So that's why your RC now is 70 parallel to the 30 ohm. Okay, so from here you have RB. RB is parallel to the 12.5 ohm. So RB here is your RB parallel to the 12.5 ohm, and then here is your RA. RA is connected to the 15 ohm. Okay, here RA is a 35 connected to the 15 ohm. Okay, so this is your new equivalent circuit. Alright, so based on this, your new equivalent circuit, you can further simplify it, where you see your 70 ohm and 30 ohm is connected parallel to each other. Okay, 17.5 is connected parallel to the 12.5, and 35 is connected parallel to the 15 ohm. Okay, so how to calculate it? You see here and here is connected parallel, so 12.5 parallel to 17.5, you can simplify it, become 7.292 ohm. So from here you can further simplify it, become 7.292. Okay, how about this 35 connected parallel with the 15? So 15 and 35, you calculate, the equivalent resistance is 10.5 ohm. So that's why here you have 10.5 ohm. Okay, 70 and 30 also connected to each other, also parallel to each other. So 70 parallel to 30 is equal to 21 ohm. So here you have 21 ohm. Okay, finally, you can further simplify it. So here and here is series. So for series, you can just add on these two numbers, and then this R equivalent for this point is parallel to 21 ohm. And then after that, you can just find your RAB. Right, so RAB is equal to 7.292 plus 10.5 parallel to 21. Okay, here 7.292 plus 10.5 parallel to the 21. So based on this, I can further simplify it. 7.292 plus 10.5, I get 17.792 parallel to 21. And then for parallel, you need to multiply first the number, then only you add the numbers. So 17.792 multiply with 21 over 17.792 plus 21. So finally, the answer is RAB is equal to 9.632. Okay, so based on the RAB, you can find your I. Okay, so your equivalent circuit is like this. Okay, you have, where's my pen? So you have a circuit. Okay, so you have the supply here. Your supply is 120 volt. Okay, so you have point A and point B. So here is your A and here is your B. So it is connected to the RAB, where your RAB now is 9.632 ohm. Okay, so you need to find the value of I. Okay, I is equal to V over R. So in this case, V is 120 divided by your RAB. RAB is 9.632. So finally, my I is equal to 12.458 ampere. Alright? Okay, that is how you solve your circuit. You solve your complicated circuit by using the transformation of the Wye-Delta network. Alright, so that's all for now. Thank you for your time and thank you for watching my video. I'll see you in my next video. Bye!